Hello to everyone else. How's it going?
I think this
Going great.
and I think it was interesting to hear somebody was downloading Plural Course videos for training, and other people were downloading car videos for their kids.
Yeah, when we lost power, we only lost it for like 6 or 7 hours at a time. So no quick downloads for us.
I lost power for about 20 hours, and the house got down to about 48 degrees. But I had trickled all the faucets, and we got a gas stove. So thankfully, I could get hot coffee and hot meals, and it wasn't so bad.
I was wishing I had a gas stove. I had a grill at least. So that one night where power happened to be out during dinner, I just grilled. That was, yeah, that's fine.
Oh yeah, I don't know how we would have survived without a gas stove. I'm pretty sure we would have resulted in cannibalism at some point.
Restaurants were still open. I went out for my lunch every day.
I never tried to go to a restaurant.
So you are willing to risk COVID and freezing to death.
6:27. We'll get started soon. You already test the stream. Of course it is. Russell is always prepared. Always ready. He's the only thing in this organization that never breaks.
Did you really just say that right before you started?
I would
That's
knock
confidence.
on wood. I would knock on wood, but I have wood colored formica. I'll knock on that. Oh. Thank you. I'll put it in Slack.
Sorry.
All right, it's 6:30. Are we ready to get started?
I'm ready.
I think we are. All right, who's got a typey keyboard right now?
Look like Alan. I don't know if you can mute people. I can't mute people, it looks like.
I do not have the power. Alan has muted himself. Sweet. Okay,
Sweet.
let's get started. Hi, thanks everyone for coming to the North Dallas Developer Group. We are glad that you are here. Also, thanks to Robert for coming in and speaking to us. Really appreciate it. I'm going to have Robert introduce himself. He was nice enough to actually reach out to me on Twitter to speak. And so I actually don't know Robert. So I mean, I could read his bio off the website, but I'm sure he could do a much better job of introducing himself. So we'll let him do that here in a minute. So thank you very much, Robert, for
You're
coming
welcome.
to us. Thanks everyone for coming. If you have questions or anything you want to say during this presentation, feel free to put something in the chat or put something in Slack. We'll have people monitoring both places, and we can jump in and interrupt Robert when it looks like he's at a good stopping point. So feel free to ask those there. And there is the which Russell posted, the link to sign up for our Slack channel. So please do that. If you're not, that's where I put the survey for what Robert was going to talk about this time. Was in the Slack channel. So if you want to participate in things like that, by all means, please join our Slack channel. Okay, I think that is all in terms of announcements. So Robert, thanks for being here. Will you please introduce yourself?
Sure. So Robert Boedigheimer, I've got a slide here that I'll show you that has some of my background on it. A little bit about myself. So my full-time job, I'm an e-commerce web developer using Microsoft.NET since 2002. I also do conference speaking. I have some Pluralsight courses. I put my Twitter and my email and blog information there. So all of the slides I'm making available. So I'll have a link at the very end where you'll have access to all of the slides. And like you said, if you have questions as we go, put them in the chat and such, and we'll try to take them as we go. And I think that's probably about it. So I'll jump right in. So first I want to talk about Fiddler, only because I'm going to use it throughout the talk. Fiddler was a tracing tool built specifically for HTTP and HTTPS. So Eric Lawrence was working at Microsoft. I think he was on the clip art team years and years ago. People would order clip art online and they wouldn't be able to download it for some reason. So they would contact support. And Eric realized there really wasn't any good way to have people troubleshoot. There was Network Monitor, some of those tools available, but it wasn't easy for the support staff to actually help people. So he didn't know HTTP, didn't know .NET, didn't know C#. It's really cool. It was acquired by Telerik in 2012, and I gave you some links there where you can download it. I'm going to show you Fiddler Classic. That's what I've been using for years. They do have a version called Fiddler Everywhere, if you weren't aware of that, that runs on Mac and Linux as well. And they're slowly moving all the features over to that. So the reason I want to show it, it's what I typically use to show traces. And I also will show you at the end that we can use it to decrypt HTTPS, which will sound horrible at the beginning of a talk about HTTPS, but I will show you why that will make sense. So I've got a fictitious travel site here. So I actually have been to Sydney, and if you ever go there, you can go up the bridge, which is super cool. Found out my dad was afraid of heights that day. I probably should have asked him ahead of time, but what do you do? So I did a request for the web page, and in Fiddler, I can see things. I would assume a lot of you have probably used Fiddler or other tools that are very similar. I can see the request for the actual web page. So here, if I take off the compression, you can see my HTML page, but you can also see the CSS, the JavaScript, all of the images and such, because in this case, I was just using HTTP. So I'll talk about browsers have been changing a lot, how they indicate whether they show padlocks, whether they don't, whether they say secure. They've been playing around with a lot of different treatments for how they want to designate whether you are definitely using HTTPS or if you're not. I happen to use Edge. I like the new Edge browser. So this is what it's showing me to tell me that this page is not secure. But that's what I can see because I am not using HTTPS. I can use tools like Fiddler or anyone along the wire, basically from the browser to the server, would be able to see all of the same stuff. So what is HTTPS? So HTTPS, it's a secure communication protocol. And you can think of it as it truly is HTTP, but over an encrypted channel. In other words, everything you know about HTTP is still true. You have all the same status codes, all the same methods, everything you would expect. The only difference is that it's running over an encrypted channel. And in this case, we're going to talk about TLS. And like I said, browsers are changing how they indicate if you have HTTPS in use or not. That's heavily in flux. One thing I did want to say, Scott Hanselman, I like this quote. He said HTTPS and at that time SSL doesn't mean you should trust this website. It means this is private. So you may be having a private conversation with Satan. So in other words, just because you see a padlock, that doesn't mean that the web server has implemented everything securely and everything's okay. It just means the conversation between the browser and that server is not going to be visible to others. That will be a private conversation. So I want to show you what the HTTPS looks like. So I'll go back to Fiddler. I'll pull up, I have the same page, but hosted with HTTPS. We'll see if I see that traffic here. And all you can see here is I've got a tunnel. So it says I did a tunnel and I went to my own machine. So I happen to be running IIS on my laptop, but it says I'm port 443. And the important thing is I'm using HTTPS on purpose because I don't want people in between my browser and my server to be able to either see things or to be able to manipulate things. So when we talked about HTTP running over an encrypted channel, there's two main ones that have been in use. So today you should be using transport layer security. In the past, it was SSL. So many, many years ago, SSL was the encryption layer. That's been broken for a long time, deprecated, shouldn't be used. I will warn you that throughout the talk, people intermix. So they like to say SSL when really they should be saying TLS, or really they should just be talking about HTTPS. So you'll even see some of the demo sites I'll show you. The domain names still mention SSL. That's unfortunate. You should be using TLS. And there's a few reasons why. So I gave you the various versions that are available. So I work on an e-commerce site. We take credit cards, so we need to be PCI compliant. So it's important for PCI standards to be using version 1.2 or above. Another note, if you're only using TLS 1.0 or 1.1, major browsers are going to deprecate those versions like the end of this month. So if your site, if you're currently using HTTPS and you're using those versions of TLS, browsers won't be able to get to your sites anymore. They're going to stop supporting those older versions. So you should be using 1.2 at least, and looking forward to using version 1.3. So 1.3 is relatively new, 2018. The innovations with that one, the main one is just it's got one round trip. So I'm going to show you how connections get established. But be aware in the 1.3 world, you can have one round trip to set up TLS. And if you visited a site before, you'll get a 0 round trip. In other words, it will remember that you had a previous TLS connection with that server and be able to immediately start sending things encrypted, which is cool. So if you haven't seen this before, I'm going to show you Can I Use. So Can I Use is a site that lets you go out and search for various features. HTML, CSS, lots of other things, and it shows you current browser support. So if I come out here and I punched in TLS, I can go down and look at the various versions and see how well they're supported by browsers. So you can see TLS 1.2 is supported everywhere. TLS 1.3 also has pretty good support across major browsers. It knocks out IE11. You'll set up your server so you can actually support multiple versions, and that'll be part of the negotiation between the browser and the server. So if you can, if your server supports using TLS 1.3, I would recommend turn on 1.3 and still support 1.2 for a while until we get more green in this picture. Again, you can look at your logs, right? If you look at your analytics and they say, we don't have any of these browsers, we just have all the browsers that are already supported, then good for you, and you can support just TLS 1.3. The other major thing that they changed in TLS 1.3 is they dropped a lot of what they would call weak ciphers. So TLS just says this is the version we're using. Within it, TLS, there's also then what specific ciphers are being used, like AES encryption, how many bits, all of that stuff. I'll show you some of it later when we look at some reports. But just be aware that version 1.3 really knocked down the supported ciphers to make sure that we're only using things that are considered strong cryptography going forward. So that's another reason to move to that. So why should you use HTTPS? The main reason is confidentiality. So I've been using HTTPS for many, many years. Like I said, we're an e-commerce site. Years ago, we only had HTTPS on particular parts of our site. So when you did the login or when you did a checkout and you had credit card, we were very concerned about the confidentiality. We don't want someone to intercept your password. We don't want someone to see your credit card. In the years since, there's been a lot more focus on integrity. So if you look at this, flying on a plane, and you're using your browser and you're on a website and you might see something like this, right? Southwest is telling me I have an hour and 8 minutes before I land. And at first you think, well, that's kind of cool. I mean, I'm on a plane and it's telling me, in a timely fashion in the bottom of my browser, how long it's going to be before I actually land. Until you start to kind of think about how exactly did they do that, right? Whatever site I was connected to, basically Southwest was sitting between the browser and the server. The server in this case was not using HTTPS encryption. So Southwest was actually able to get the web response from the server, and it modified it by putting this modal at the bottom of it. So luckily for us, they did it correctly, right? They didn't crash my browser. They could have. This could just as easily have been malware. So years ago, like I said, I was really worried about confidentiality. My joke at the time was, grandma's quilting site probably didn't need to use HTTPS. Nowadays, grandma's quilting site needs to use HTTPS. I mean, there's no sites that can get by with not using HTTPS. I'll try to convince you of that throughout the talk. But what really changed my mind is this integrity. Having people in between that can intercept and inject content into what I'm trying to serve to my clients, giving them malware or just breaking my experience, right? If they had something wrong in this banner, they could have easily have broken the web page I was at. And the people who provide that server would have no idea it was intercepted and why it was broken. It's also useful for authentication. So you do have some, and I'm going to show you certificates, you do have some level of authentication where you can tell which server you're talking to by looking at that certificate and having some understanding of who you're dealing with. You can also use optional client certificates. So I was kind of surprised. I thought years ago when client certificates came out that possibly government agencies by now would have given us client certificates to install on our machines. So I could prove to government agencies that I am who I say I am because I have this certificate on the client. So there are a lot of places that are high security that take advantage of using certificates on the client for doing authentication as just another proof of who they're talking to. So that's why we want to use HTTPS. I'll show you a little bit of background. So if you go out to build with, you can actually see major websites, what kind of technologies they use. And as again, you can see they're still referencing things as SSL. But they actually track major websites, and they have found what percentage of the top 10,000, 100,000, and million sites use HTTPS by default, meaning either they support it, or if I type just the domain name, they will redirect me to use HTTPS. So I'm going to show you another graph in a minute, but since 2014, 2015, browsers really started pushing that you needed to use HTTPS using various levers. And so these numbers have really been increasing. If you were to go out to all of the sites, like the internet, as far as all the sites that Built With and others archive, you'd be down to less than 1% actually use HTTPS, which just says obviously major sites are using it. As you get to the really small sites, a lot of them are not. You can also look at telemetry about Firefox. So Firefox puts out a graph of what percent of all of their traffic. So before we were looking at major websites, do they use HTTPS or not? This is actually just looking at, I'm running Firefox. If you opt into Firefox telemetry, where you're sending your data to them, they're actually recording what percent of all of the page views of everyone that's opted in using Firefox, what percent use HTTPS. So you can see, I don't know why it's a global, but they list just US and Japan. So I just left USA on here, and you can see that globally, it's at about 82% or so. And if you look at I'm sorry, yeah, the globally is about 82. In the US, it's higher, somewhere in the 80 plus range. Just showing you that even though not all websites use HTTPS, most people are using sites that use HTTPS, the major social media sites, etc. So that just gives you a little background about how much this has been rolled out. And again, you can see browser vendors started making a real push to get people to adopt it. So you can see that back in 2014, we were down more at about 25%, and that's tripled basically by 2021. So how does HTTPS work? So I'm going to show you, this is actually every version of TLS up to 1.2. So by default, you've got your browser and you've got your server. You need to do a TCP connection. So this is the standard handshake that happens to set up a TCP connection. On top of that, once you have the TCP connection, then you start doing the TLS exchange. So the client will send the server, we'll get into the server certificates, but the server will send a certificate saying, I'm this domain, here's my proof. It'll go back to the client. The client, I won't have time to get into it all here. I've got a talk on Cryptography 101 where I get into symmetric and asymmetric, but the certificate is an asymmetric public key. When it gets to the client will actually use symmetric encryption because it's a lot faster. So it'll generate a random symmetric key. It will use the server certificate to encrypt that key. It sends it to the server, and now the two of them can start to talk. So I gave you a link down here where you can read up on all of these specifics. The only thing that really changes when you start looking at TLS 1.3, this handshake doesn't have to go back and forth twice like that. It only has to do one to get that connection. And then like we said, if you've been there before and your browser remembers you've negotiated a TLS 1.3 session before, it'll be 0 round trip. You'll just need to do the TCP connection and you'll immediately be able to start doing encryption, which is cool. So hopefully that makes sense. That's some of the setup time that's involved with getting both your connection and getting the encryption to work. So the next thing I want to talk about it as somebody who hosts a website, I need to get a server certificate in order to start using HTTPS. So there's lots of different types. I focused on the two main ones. The main one virtually everybody uses today is called domain validation. So I will go to a certificate authority, and there's a process that it's different for each one, but I will essentially go to, let's say, Let's Encrypt, which is a free one. I will go to them. I'll say I want a certificate. I'll send them an initial file. They will then say, prove to me that you own this domain by dropping either a file into your root folder, or we want you to add something to your DNS entry. And by doing that, the certificate authority is basically proving that I have admin rights over whichever domain I'm requesting a certificate for. In other words, I wouldn't be able to do those things in theory if I didn't if I wasn't the owner of that website. So that's what most people do. There was something called extended validation certificates. They still exist. Essentially, the bad news for people that had them, you went through a little more work to prove who you said you were, and then the browser would reward you by doing things like this. So if you remember this, browsers would show something like this, that, this is definitely Twitter, was an additional thing they put next to their padlock, and they really emphasized it, and that proved that you were using extended validation. It just gave the browser user more comfort that you were actually the website you claimed to be. Turned out they were a lot more expensive to get. So when you went to a certificate authority, you had to pay more, it took more time, and it turns out that most people on the internet had no idea what that was. They didn't feel that the lack of having extended validation made them any less likely to trust the website they were on. So basically the browser vendors said, we're not going to show this anymore. So they dropped that indicator, which basically was the only real value you would get from extended validation. So it's essentially not useful anymore. So we're just going to focus on domain validation. In order to get a certificate, you need to work with a certificate authority. So there are tons of certificate authorities. The way the certificate authorities work is, like I said, I'm going to create basically a public-private key pair. I'm going to take my public key and I'm going to work with a certificate authority. And what I want them to do is they're going to prove I own the domain, and then they digitally sign that certificate saying, I'm Let's Encrypt, and I'm saying this is a valid certificate because this is the person who owns that website. So browsers know trusted certificate authorities. So they basically have in this case, Windows and operating systems, because I'm on a Windows machine. They have a list of trusted certificate authorities. So any certificate that's signed by one of those authorities, your browser will believe and trust that that is the right process was followed, and you're on a site that matches what that certificate authority is basically vouching for me and digitally signing my public key, if that makes sense. Okay. I'll show you, because we all run different things and we have different hosting environments, I'm not going to try to show this whole process start to finish, how you exactly ask for a certificate. I'm a developer. I've done this before. I don't want that to be the focus of this talk, but I do want to show you. So Let's Encrypt has become incredibly popular. And so it happens to be a free one. You can come out here. So I created just a Windows virtual machine that I host in Azure, and I wanted a certificate for it. So I came out here, I followed the documentation and the process, dropped the file I needed into my website to prove it was me, and Let's Encrypt then issues me a certificate that I can use to do all of my HTTPS work. I've been asked in the past, they're free. Some of the certificate authorities that were making money obviously weren't happy that now there's someone doing this for free. So there was quite a bit of misinformation about, are they really secure? Are they trusted? They are well known. They follow good processes. And the important thing is the certificate is not what controls how good your encryption is. So in other words, the strength of the encryption used between your browser and your server is based on the version of TLS you're using and specifically which ciphers you have implemented. So if you're using strong ciphers with a Let's Encrypt certificate, you're going to be just as secure as anybody who pays money to purchase a certificate. One of the other things Let's Encrypt did is they have 90-day expirations. So most certificates years ago were multi-year, or a lot of them were annual. Within the last few years, the certificate industry basically said, we're going to only support 1-year certificates. The browser vendors said, we don't want certificates to be longer than that, and they started to enforce that. Let's Encrypt is 90 days. So depending on your trade-offs, In particular for my company, we're still not using Let's Encrypt. They'd rather do the annual, pay whatever the amount is, just to be able to have less maintenance to update this every 3 months and make sure we do it on schedule. Turns out with Let's Encrypt, it's set up to be automated. So I was working on this actually last night. I had started up my virtual machine again. I had got an email from Let's Encrypt saying my certificate was about to expire within 20 days. So I spun up my virtual machine. I actually use a product called Certify the Web. There's a lot of different tools you can use, but you can configure that and say, as soon as my certificate gets within X number of days of being expired, it will go out and automatically work with Let's Encrypt to get a new version of that certificate and get it installed in IIS for me. So essentially, once I go through the initial process, I have the certificate, I can set up the renewal to be automated. So I just never have to worry about that again. And like I said, it's nice because I had my virtual machine turned off. I had forgotten that. I just use it when I'm doing particular demos and such, but I got the email to remind me, you know, you need to go get your certificate updated. So I spun up the virtual machine and made sure that ran. So that's Let's Encrypt. You can use any certificate authority you want. Like I said, once you have the certificate, in my case, I install it with IIS and I say for this domain, here's my certificate. And then we looked at kind of how the connection gets established. There are also what's called self-signed certificates. So I'll show you in my case, because I'm hosting this website on my own machine in this case, I'm going to go back to my HTTPS. There's a couple different places you can see information about certificates. I'm just going to go to the certificate here. I can see the time period for how long this certificate is, but if you look at issued to, if I look at the certification path, there's no certificate authority. No one else signed this for me. It's what's called self-signed. I want to use HTTPS to test locally on my own machine. So I want to use HTTPS, but I really didn't want to purchase and manage certificates for every one of my developers. So we actually just use self-signed certificates. So it's fine. I happen to use PowerShell. There's a lot of different ways to request a self-signed certificate, in my case in Windows. But the negative would be if I set this site up on the internet, anybody who came and visited that site, it's not signed by a trusted certificate authority. So your browser would come up and say, by the way, we don't know who signed this. You probably don't want to trust this. And I'll show you a couple screenshots of what that'll look like later. That's the negative of using the self-signed. Obviously, you can't use it on the internet in the wild because no one's going to trust it. But it's a handy, free way to run it on my own machine. My other opportunity would be I could set up Let's Encrypt and get my own certificate and do all of that and automate it if I wanted to. Self-signed on a developer machine is actually easier for me. And lastly, there are people that obviously have cheated and tried to get certificates for domains that they don't own. And so the industry came up with what they call certificate transparency. So I'll show you how this works. Today, the major certificate authorities, when they issue a certificate for a domain, they will write it out to a log. And you can actually go set up, if you go out to this site and you look at it, you can set up and say, I want to monitor my domain name and be notified anytime somebody creates a certificate. So if somebody were able to trick a certificate authority into issuing them certificates, you would be able to get notified that, you know, somebody just issued a certificate. You could say, I know that's not me, and you could go investigate what went wrong. So this is just kind of a new way to have some trust that other people are not tricking certificate authorities and getting certificates for sites that you own. So you can come out here and read all the details about how it works, but I just wanted you to know that's a relatively new thing to fight people that are getting certificates they shouldn't get, if that makes sense. So I don't know, are there any questions, moderators, in the chat that you want to go through before I go further?
No questions yet.
No questions yet. Awesome. All right. So that is certificates. Like I said, it's very easy to get free certificates, and the web servers that you're using or the hosting providers. A lot of hosting providers, like I use Azure Websites, they actually use a wildcard certificate. So all I need to do, I create a new site on Azure Websites. I just checkbox and say I want to use HTTPS, and it automatically uses that shared certificate, which is managed by somebody else. So I really don't even have to deal with it at all. So if you're lucky, your hosting provider will take care of most of that work for you. But if not, like I said, I spun up a brand new virtual machine, and it was pretty straightforward to get. The Let's Encrypt certificate was really easy to get. Setting up the automated process to make sure that it would go get renewals, I've had a few more stumbles with, but it's not that hard to set up. Okay. I want to make an.
If now's a decent time.
Yeah, sure.
Each will ask, can you explain X509 and generating child certificates? Can a root be obtained from Let's Encrypt?
So I got to see if I understand the question correctly. So you wanted to know, so X509, when we talked about certificates, there are root certificate authorities have root certificates that they can use then to sign other things. So is the question like if I wanted to run my own local, people run their own PKIs, where they want to be able to issue their own certificates? Is that what you're hoping for, is that you could issue certificates for your own subdomains, say within your company, and you wanted to know if Let's Encrypt lets you do that?
So the solution that I'm working on is an IoT solution. And so in an IoT solution, you've got, you're the owner of all the things. And you're going to have your manufacturer build things for you. So you create a child certificate, you give it to them, they can encrypt, they can then generate their own child certificate, put it in the TPM, so that that device has a certificate that's derived indirectly from your certificate, and you can use it to verify that, hey, yes, that really is my device, and it was also made by that manufacturer A.
Yep. So I think I could make out your question a little faint, but the idea, you're talking about IoT devices and you want to embed certificates into devices for doing things like client-side authentication, like we talked about earlier, where you could actually prove that this certificate was basically baked into this device, and you want to know if you can sign it with something your company essentially owns, so that all of those devices can roll back up and trust. I haven't looked for that before. I'm not sure if Let's Encrypt lets you take or create a root that you can then use to sign other stuff. I'm honestly not sure. Okay. If you want, when we're done, you can send to me and I can help you look. It's a very good question. So that kind of goes back to when we talked to the very beginning, why do you use HTTPS? That level of client authentication is a great idea, right? You don't want to store passwords and stuff on IoT devices. If you could get an issued client certificate that you could prove was issued by a certain company or root certificate. So it's a good idea, and we'll just have to dig into whether Let's Encrypt lets you get that kind of certificate that you can then use to sign other certificates. Okay.
2 more questions.
Sure.
One, does let'sencrypt.org issue wildcard certs?
Also a good question. So the wildcard certs, let me go back and show you what they look like. So I'm using that. I mentioned that for Azure. So let me see if I can find, I've got my Azure one here somewhere. So like I said, I host on Azure websites, so give that a second to actually pull up. And you'll see that certificate uses a wildcard certificate right there. So any Azure websites.net, so Microsoft is managing that wildcard cert, and that's what makes it where I don't have to do work to get my specific domain when I create it. It just gets, used by that general certificate. And so the question was, does Let's Encrypt let you do wildcard? I'm not sure about that either. I have not looked into that. I would imagine that they would, but I have not looked.
All right, next question. How can I tell what TLS level is being used either in browser or in IA?
Very good question. So you can see basic things by clicking, and I'm going to show you an edge. If you go into developer tools, you can actually go to the security tab and it should tell you right here. I don't know how well that's visible, but it says it's using TLS 1.2 for my connection to my Azure website. And then it lists out the specific ciphers that are used. So this is where we were talking about TLS is interesting, but it really boils down to what are the actual ciphers being used for the cryptography. This is really what's key. And I'll show you a site later that will tell you which one of these are good and bad. I don't know out of the 300 of them that are supported, I've got a site that will break down for me which ones are currently considered strong, okay, or weak. I know AES 256 GCM is a very good one today, but a lot of the other ones I don't know. But that's where you can see specifically. You can also see, I'm not decrypting in Fiddler right now, but I believe if we were to go in here, I believe some of this connection information has some of the same stuff where it talks about, like right here, I'm using TLS 1.2, and it talks about some of the ciphers again. So there's multiple places you can see that. Fiddler will show that. And like I said, Dev Tools in the security tab will show you that level of detail as well. Okay.
All right, no more questions.
All right. It's important to know what's not encrypted. So even though you're using HTTPS, the IP address you connect to and the port of the web server you connect to, and also the host name is visible. So in other words, if you're at work typing, you're going to an HTTPS site, maybe a questionable site from a business perspective for whatever reason, just be aware people who are watching the traffic, like even when I look here in Fiddler, I can still see everywhere you're going, right? You can see I've been to Can I Use, you can see I've been to Let's Encrypt. So I can see some of that. I just can't see the details of what's happening in that actual connection. So you just don't want to think that, hey, just because it's encrypted, people can't see anything. They can actually see the sites you're connecting to. And if they have the right tools, they can see how long your session was and how much data you transmitted. Like, did you spend a lot of time on that site? That stuff is not protected with HTTPS just because this stuff is required for the browser and the IP layer and everything to actually do the connections and send packets. So that's not something they can encrypt. So I just want you to know that that stuff will still be visible, if that makes sense. So far we've been talking about how do you set it up? Why do you want to set it up? So now I want to work through you're a developer and I want you to know. So years ago, we only used it on particular sites when we had specific information like passwords or credit cards we wanted to protect. It turned out probably about 3 years ago is when browsers started to do this sort of thing, where they would say it's not secure. That's a pretty bad look for us, as at the time, the company I was with had lots of different brands, and they're major brands that people would go to that site. We couldn't afford to have it say that. So even though it was, at the time, again, it was a static website, back then we weren't as worried about the integrity. As soon as the browser started to do this, it made it where we really needed to use HTTPS. So we made the commitment that we were going to switch every website, every public facing website we owned was going to switch to HTTPS. So a couple of things we ran into, I just want you to be aware of as a developer that these things will come up and how do you fix them. So the first warning is social counts. So if you have a like button on one of your pages, those like buttons are tracked using the URL, which is protocol specific. So in other words, if I had 150 likes on my HTTP page today, as soon as I switch it over to HTTPS, it's effectively going to reset all of your social counts. Like I said, we're a marketing site. We were mildly annoyed by that. Not enough that would have stopped us from doing it. There were some kind of odd sounding products that claimed that I could try to make a transition in some way and carry those numbers forward. We didn't deem it worth going after. I just want you to know if that's important to you, that switch, you will lose your social counts. What we ran into a lot more than that is what's called mixed content warnings. So I want to show you what they look like. I put this, I'll go back here. I put this in italics because browsers are constantly changing and they differ about how they warn you about these two problems. So I'm going to show you the first one, and I'll actually go in Visual Studio Code here and just show you. The first one is if you have what's called passive content. So I have a page here. I'm going to host it using HTTPS. But if you can see, I accidentally referenced one of my images using HTTP. Images, most browsers consider to be passive content, meaning that if I were to pull this image using HTTP, it's not something people will typically inject malware into. The browser vendors feel the images are somewhat innocuous, and so they're not as worried about images as they would be about things like JavaScript. So this is what's called passive mixed content. So a while ago, if I would have gone to this page, it would not have showed a padlock. It turns out the browser vendors said back then they would say not secure because not everything on the page was actually using HTTPS. Just recently, last few months or so, the browser vendors have been changing, and the major new ones are automatically upgrading those requests to try to use HTTPS. So in my case, I do support HTTPS at this link. I just accidentally did it wrong. So if I were to go into developer tools here again, and I'm just going to go to the console, and I don't know how readable this is, but it says, hey, you requested an insecure element, HTTP, and it tells me what it is, which is helpful. So I can go track it down. But it says you have that wrong, but we automatically upgraded it to HTTPS. And they have a link to where Chromium started to do that for you. So this used to be a pretty decent sized problem. You know, even a few years ago, you'd come here, you thought you were using HTTPS, you wouldn't see a padlock. The tools weren't very good about telling you which file you were referencing wrong. The browsers now have made huge strides to just specifically tell you what's wrong. Like, this is what's wrong, go fix it. But they're also now just masking it from you. They go and connect in the background using HTTPS. And as long as that worked, they're just going to serve it like nothing was wrong. So here's my image and everybody's happy, if that makes sense. There's also active content. So if I go back and I'll show you what active content would look like. Here I'm trying to pull a jQuery file and I'm pulling it accidentally using HTTP. Browsers consider JavaScript to be an active problem, not passive, meaning people could inject malware into that JavaScript and they would have a lot more control over my user experience by messing with my JavaScript file. So if I go back to Edge, I'm going to hit that page. I'll do Control F5 here, and it looks okay. It says it's using HTTPS, but if you notice something here in a minute, my carousel is no longer automatically spinning here. And if I try to click it, it's actually dead. And so why it's dead? If I hit F12 and I look at the console, it's going to tell me that I have mixed content right here. But because it's insecure script, it's been blocked. And so by default, this is what browsers decide, right? Each one is deciding what they want to do. Edge is based on Chromium now. So they made the decision that they don't want to serve insecure JavaScript files. Rather than automatically upgrade them to try to use HTTPS, they're just going to block them. So I want to show you, there's a couple ways to fix these things. The first, I can do this if you've never seen this before. I can do what's called protocol-less URLs. So I don't need to specify. it's going to use whatever the page uses. That way, this used to be a big deal years ago when I had stuff on my website where I was doing some HTTP and some HTTPS, and I had them in shared components that were used on different pages. This was a very convenient thing to do because it just picked the right one to use based on what the page did. I could also just type HTTPS everywhere, right? If I'm referencing from my own website, I'm just going to do this, right? I don't need to specify protocols or domain names or anything. It's only when I'm referencing things from a different domain. So let me show you another fix. There's also a content security policy header. So I'm going to show you there's two different settings for this, and I included both of them in here. You can put it in as a meta tag. So only because I'm doing it in a demo and I want to give you code, I put it in here as a meta tag. So I'm saying I have a content security policy. If your browser understands this policy, I'm telling it to force upgrades of those requests. So this would give me consistency across the browsers. I'm basically saying if you come here, even if I have this referenced wrong, I want you to switch to HTTPS for me. So let's go run this and see what this one does. So if I do this, everything should be okay. And if I look at this CSP upgrade, if I roll down here, I'm still referencing this wrong. So I'm doing a JavaScript wrong. But because I put that meta tag in, I'm basically telling the browsers, and even though Chromium doesn't want to do that, it would have blocked it, I'm telling it, please upgrade it. So I'm forcing consistency, and major browsers understand content security policy. So I would get the desired effect, where if I'm doing things wrong, it's going to automatically try to switch them to be HTTPS. Okay. I would never honestly do this. You can actually come into, I'm going to show you IIS. This will be one of the rare times I'll show you in a website. You should be able to do this in whatever server you're in. But if you go into the response headers, there's this content security policy. I just put remove on here so it wouldn't be used. If I take this off and hit OK, I'm telling it at a server level to give this as a response header. So now every page on my entire site will do whatever this content security policy is. So basically I'd say across my entire site, any place I'm misusing HTTP resource links on an HTTPS page, please automatically flip them and try to use HTTPS. Okay.
We have a question.
Sure.
So would it show unsecured if your site didn't allow retrieving the image with HTTPS? And that goes.
That's a good question. I was thinking that as I was saying it too. I have not tested that. So the question I think is if I told it to upgrade, and I'll just pick this example, right? If I said, please go try to upgrade and use HTTPS, and let's say it tried, but this host didn't support HTTPS, the question is what would happen, right? I haven't actually tried that. I should try that. If that failed, I would assume the browsers like Chromium will still say that's an active one, and they would still block it. So in that case, I think your carousel would still be dead. You'd still have the padlock. I mean, again, this is totally browser dependent, right? Some of them don't show that it's secure when they block stuff, so you'd have to test that out. My assumption is the active stuff, if it didn't actually work with HTTPS, would still get blocked just like it does now. And I'm assuming that in a Chromium world, they would let images go still serving HTTP, if that makes sense. I think they would still show the image. They tried to use HTTPS and it failed. I think they would show it, but I would have to test that to know for sure. That makes sense? So I was going to say, I'm not that nice. I actually do block all mixed content was my strategy. And so I can do the same thing. If you look at the block, I'm telling it if somebody doesn't have it coded right, block it. And I have a couple schools of thought on why I do this. The first is that people should test, right? It annoys me when people don't test things. If I set this to block all mixed content, I'm going to ensure that browsers that understand this, if you have your stuff wrong, you're going to find out, right? If you test your stuff, your images will be broken and your other stuff isn't going to function. So let me go run this one. Maybe this will answer what we were asking too. We'll see. So that's what, in this case, let me see. I think I used HTTP for that one. And they change so often, I apologize. They switch what they do, so I'm never quite sure. So I used HTTP. I told it to block insecure requests, and it looks like Chromium said I'm going to try to go get it anyways. In this case, my server probably actually supports HTTPS. So, but the idea would be, I want to say block because I wanted in the past things to intentionally fail so people would find out if they tested and they would actually go fix their links, because back then, not every browser supported this. So if I didn't find out what was wrong and fix it, some old browsers would be just wrong. And so that was my philosophy on doing it. And again, I just set that at a server level. So I just went on my servers and said content security policy, block all mixed content. And we found out, right? I mean, as we started to roll out, we found places where people had stuff coded wrong and we fixed them. So those are most of the problems people run into when they're switching, is just referencing things wrong. So back to that question, I mean, you do run into that situation where if you're working with a particular vendor who doesn't support HTTPS, you're going to have to test it out and see in the major browsers today, what do they actually do if they try to go out and use HTTPS and it doesn't work. To me, if you're working with vendors that don't do HTTPS in 2021, that's a pretty big deal. I mean, that's a pretty big problem. And I'll get into why there's other reasons why you want HTTPS as we go forward here. But so assuming you agree and you want to get to HTTPS, this is the strategy I would recommend. So to start with, you obviously have to get HTTPS supported for your site. So in my world, I had already used HTTPS forever. I had certificates, I knew how to use it, but I was only using it on part of my website. If you don't use it at all, your first step is obviously you need to get your servers set up so that they support HTTPS. So your first task is that, right? Make sure your server can do HTTPS or HTTP so that you're able to test and make sure that it works in production and everything, okay? Once you get to the point where you know that HTTPS is working okay, then I recommend you set up what's called a 302 redirect. So if I go show you what that looks like, I've got for IIS, I've got URL rewrite. So this is actually a product that lets me rewrite requests that are coming in wrong. So you can use various techniques to do this. And what you can see in here is I just say, if I see anybody who's coming in using HTTP, I'm going to redirect them to use HTTPS, pass on whatever the URL was before with its query string, and do it in a temporary way. So let me clear out my fiddler here. I'm going to turn this rule on because right now it's not enabled. So by default, I was just, if you typed HTTP right now, like I did here, right? I was showing you that I just allowed you to continue, right? You're just not secure. If I turn this rule on and all is right in the world, I'm going to go run this again. When I go hit this same thing, you can see that it got upgraded to HTTPS. And if I look at my request here, it's going to show a 302. So what I'm saying by that is temporarily, I'm telling the browser, you came to a specific URL trying to use HTTP, and you should use HTTPS for this request. So it told the browser to, hey, come back and ask for it using HTTPS, which it did. And then as I travel through the rest of my site, you'll be secured. So the way we did that is we made sure our site worked. We did this for about a week or so. You know, do it as long as you need to get comfort with. Make sure that things are functioning using 302 redirects. The next step then is you say, okay, I've tested, I've run, there's nothing wrong in production. I can go into this rule and say, now I want this to be a permanent redirect, a 301. And what you're saying then is you're going to tell the browser that I want you to switch from HTTP to HTTPS for this specific URL. I want you to store that and do that permanently. So if I were to turn that on and go hit apply here, let's go back and do this request again. I gotta get back to my original. And you can see now it did a 301 redirect. So what does that mean? Well, if I didn't show you this, but when I did the 302 last time, had I come back, it would have still tried to use HTTP. I would have told it again, 302, you should be using HTTPS. This time, if I try to go back to it using HTTP again, it should just go directly there. It's just going to directly come to my site using HTTPS. You don't see that request with a redirect because the browser stored for that specific URL. Please don't come back using HTTP. Use HTTPS. That's cached in my browser. So the reason you did this in steps is because if you have something wrong and you set up a 301 redirect right away, and then you have to back your stuff out back to HTTP, browsers that have it cached are only going to come with HTTPS and they'll break. So that's why you kind of want to do this in steps, if that makes sense. Once you've run that way for a really long time, you can take this next step, which is called HSTS preloading. So I got to talk about one more little step in here. Strict transport security. And this is where I'm telling it, again, I'll show you this in IIS. This is another header. You can see I just have the remove on it. If I take this off, what this is going to tell the browser is, I want you to only use HTTPS for this entire website for this number of seconds. So for once I got my 301s to work, I would come in here and say, I want to use strict transport security. I would do it for 120 seconds at first. What that tells the browser is when I came to HTTP like this, it did a 301 redirect, but it also told the browser, not just this URL, but let's say you had another URL. You're just telling the browser any URL for this website, only use HTTPS going forward. That's what this strict transport security thing will do for you. Okay, so that's the, go ahead.
Do 301s get cleared at any point?
They do if you clear your cache. So if you were to clear your browser cache, those would go away. I don't know, standard cache clearing, like when your cache gets full occasionally, I would assume it keeps the 301s around for a while and throws out images for websites. But I don't know. But I know if I were to go do a, clear my cache right now, it would forget the 301 redirect. And the other negative, the other advantage of this one is the 301 redirect only helped me for specific URLs that I redirected. So like I said, when you came to the first one, it stored that it wanted that first request, just this one. There'd be something in the cache saying, if you ever see HTTP for just this URL, go to HTTPS, but any other URL it saw, it wouldn't. The strict transport security, you're literally telling the browser, stop using HTTP for my site, no matter what the URL is. That makes sense? So you want to get to here. So if that makes sense, there's one more step that you can do. I was jumping ahead of myself here. You can go ask to be preloaded. So if you think through the flow that I just said, if I set up everything I just said, the problem is the very first time you find out about my domain, you come and type it into your browser, that very first request to get to my server, before I can tell you, hey, please come back using HTTPS. And by the way, strict transport security says do that forever. By the way, I didn't say this. Run with 120 seconds at first, just to make sure it works, because it's a pretty big deal if you're wrong. And then make this much longer. Like we set ours to whatever the max is. I think it's a year. So that if you come to us once and you find out we only want HTTPS, that browser will keep using HTTPS only for the next year. The trick with this next thing is you can come out here and if you follow a bunch of rules, it doesn't work for my website, long story. I won't get into it here. If you can comply with all of the rules out here, you can get baked into a browser list so that they know your domain should only use HTTPS. So that way that very first trip will never happen either. You go submit it. Eventually all the browsers get this baked into their lists. And then anybody who comes to your site and types like they have here, example.com, right? If example.com had done this, if I just came here the very first time and type example.com, my browser would know never talk to them using HTTP because of this preload process. So if you can do it and you know your site works and you know you're never going to go back to HTTP, that's where you want to end up because that very first transmission can never be stolen either. That make sense?
Yep.
Okay. So the other reason you want to use HTTPS, there's a whole host of features. Browser vendors basically drew a line years ago and said, you need to use HTTPS. If you don't, here's all the features that you can never use. So you can't use HTTP2. You can't use HTTP3, which is coming out pretty soon. You can't use JavaScript service workers. Geolocation stopped working. So we had years where I had a website, back when it was the brand sites and you could come out and type in a zip code or it would use geolocation and automatically figure out where you were. And it would show you stores close to you where you could buy our pizza, for instance. One day Chrome just said, we're not going to do geolocation anymore. So we didn't realize this rule had changed and none of our geolocation worked on our maps anymore. So they just started drawing new lines and saying, if you don't use HTTPS, they're basically saying any new feature we're going to add into our browser that you might want as a developer, you can't have if you don't use HTTPS. So this is the other thing that's going to drive you eventually to have to get there. The next one that's really new is browser HTTPS only mode. So I was surprised this has not happened before, but let's go out and show you what this looks like. So Firefox is the first one to do it. It's not on by default. So I actually went and turned it on. I think it's just a matter of time before browsers make this the new rule going forward. So if I go into security, at the bottom, there's an HTTPS only mode, and I'm just saying only connect using HTTPS. So for instance, if I were to come out here, there's httpforever.com. This is a website that's intentionally staying HTTP so people can use it for testing. If I try to go there when I've got this setting set, let me see why it is not HTTP. Sorry, I'm missing an E there. This is what I get. My browser is going to say, hey, this site does not support HTTPS, so you really shouldn't go there. This is eventually how browsers say not secure today. They're going to end up at this, and they're going to start putting things in front of people like, just please don't go here. It's really a bad idea because they don't support HTTPS. Will they ever get to the point where they say, we won't let you go to HTTP? Who knows? But they're going to make it incredibly painful, and you don't want your customers to see something like this, right? So again, this is something that just came out relatively recently for Firefox. You have to turn it on. The more this gets built into browsers, I'm going to turn this on in all my browsers because everybody just goes and types domain names, right? They don't typically put protocols on the front. It'll force it to try to use HTTPS. Otherwise, it's going to give you that kind of a warning. So that's your other carrot or stick, however you want to look at it, that you eventually need to get to HTTPS. A lot of people have concerns over the years with HTTPS. And so I just tried to take the major arguments people would use about why they don't think they want to use it for their website and what the answers would be. So in other words, people say it slows it down, right? There's a performance impact to doing this encryption. So I've got, you can come out here and look at this. There's a lot of research, a lot of details where you can read about why it's not that bad. I want to show you, I kind of hate this demo. I kind of like it. So here's a site that's using HTTP, and it took about 4.1 seconds. I'm going to flip it to use HTTPS, and it took 0.65. And at first, it's really a head scratcher. Why? Right? HTTPS does encryption. Why would that be that much faster? Well, it turns out that this one's using HTTP 2. You can't use HTTP 2 if you're not using HTTPS. So it's kind of sneaky. It's not because of HTTPS this is faster. It's faster because I have HTTPS, I can use HTTP 2. If you know what HTTP 2 does, it said instead of having only 6 connections per host, it multiplex every request on a single connection. So in this world, it has to go 6 at a time, basically, because there's only 6 connections per host. But in this case, it can go as fast as the server can send it. So I like this as a demo. What I don't like is, I don't have a web page that has 360 check marks on it, and you don't either, right? I mean, it's a little bit skewed to be not realistic. The average web page has about 100 different resources on it. I maybe have 50 on my pages that come from my CDN. So it's very true that by using HTTPS and HTTP2, those 50 are going to be a lot faster. But it won't be quite the spread for speed. So test it out for yourself. But the performance arguments go away when you can start doing things like that. From a cost perspective, people used to say that a lot, like I can't afford the $150 or $200 a year for the certificate. Let's Encrypt really erases that argument. I think they're the top right now as far as the volume of certificates they issue, and they're free. And so there's not a cost argument. You can argue it takes a little more time to configure your servers, but from a pure, you don't have to pay for certificates anymore. Years ago, you couldn't troubleshoot. And so I would use Fiddler. I would be able to trace my website all the way up until I got to checkout. And then suddenly it went dark because it used HTTPS. I couldn't see anything. Both Fiddler and Wireshark can be set up to do decryption. So I want to show you how to do that. And again, at first that sounds like absolutely against everything that I have said for the entire day, but I'm going to show you why it actually works that way. Okay, so I'm going to open up Fiddler. Again, Fiddler is sitting between my browser and my server, so it's exactly what I don't want to be able to see my traffic, right? So if I request that page again, you'll see all I can see is that tunnel. If I go into Tools Options, I can go to HTTPS and I can say, please decrypt HTTPS traffic. So when I do this, I'm going to get a bunch of pop-ups here. So what Fiddler's going to do is it says it's going to create, it's going to act like its own certificate authority. So it's going to ask me right now, will I trust Fiddler to create certificates for websites? And this is safe on my own machine, right? I'm the one in the middle. So I'm going to say, yes, I want my Windows to trust the root certificate. It'll say, are you sure this is how it's going to be named? Are you sure you want to trust it? Yes, I do. Please confirm. Yes, I do. Yes. Okay. So now what I've done is my machine now trusts Fiddler to create certificates. So now when I come over here and request this again, if I were to go into here, you can see that suddenly I can see my traffic. And if I go look at what's happened, if I go back here, you can actually open up my Windows Certificate Manager. And if I go into Personal Certificates, you can see here's the root certificate. You can also see that Fiddler issued a certificate that looked like my web server, but it was created by it. So if I were to do this with something like Bing, my browser wants to go out to Bing and get its certificate. Fiddler's sitting in between, and because I trust it as a certificate authority, it's going to create a certificate saying, I'm Bing. Therefore, on the client, it'll be encrypted from the browser to Fiddler. Fiddler will use, because it created this server certificate, it will decrypt it. It will go out to real Bing, get its HTTPS certificate, re-encrypted on the wire. So it's still encrypted end to end. But because I trusted Fiddler to be a certificate authority, it's impersonating these servers, which allows me to do the decryption and see the traffic. So it seems odd at first. It seems like that's evil, but I'm intentionally doing it. I'm intentionally trusting it to issue those certificates. And then now I can do the decryption I did before. I also gave you a link to Wireshark. If you've used Wireshark, Wireshark's more of a low level, right at the Wi-Fi or Ethernet sort of level tracing. It's not a proxy like Fiddler is. The way Wireshark does decryption, you actually go in and set up an environment variable in Windows saying anytime somebody creates an HTTPS key, store the key in this folder. And so what it does is every time that I talked about the encryption keys being used, every time that key is created, it actually saves a copy, Windows will, into a folder. Then you can tell Wireshark when you need one of those keys, here's the folder. And so basically you've stored all of these encryption keys. Wireshark knows where they are. So Wireshark sitting between the two can decrypt as well. So again, the important news is just, even though you're doing HTTPS, when you're a developer, you can set it up so you can still see everything. So the argument that, as soon as I use HTTPS, I won't be able to troubleshoot any of my problems goes away.
Does anything bad happen if I forget to delete the Fiddler cert?
Does anything bad happen? Anything bad? So I leave mine all the time. I mean, once I set this up like that, it is just always it's always there and it can always be used. Because that Fiddler root certificate only exists on my machine, like on this actual laptop, and it's specific to my machine. No one outside of me. So if you're asking, like, could somebody else try to act like they were the Fiddler certificate authority and suddenly be able to decrypt my stuff? No, because the actual certificate it created is physically only stored on my laptop. So from that perspective, nobody other than me on my machine using Fiddler will be able to do that decryption, right? If I forgot that I had set this up and then suddenly thought I shouldn't show you how to do things that are evil. You can actually come in and say, don't hide Fiddler when it's minimized. The worst case somebody could do is you forgot you set this up, or they set it up and they run Fiddler on your machine and minimize it. It won't show up in your tray if you set that thing, and you'd be browsing around thinking that you're secure when you're really not, right? Because Fiddler's decrypting it. I can see that when I go look at the certificate. I can see this, right? If I take the extra level, like I do this, if I'm working with, say, a Vanguard or a Fidelity, and it's a really important thing, and I really want to know that I'm talking to the right place, I'm going to go look at the certificates. You'd see this, right? To tip you off that you really, this isn't really coming from Bing or whoever. This is really Fiddler signed this, if that makes sense.
Could malware take advantage of it? And,
malware would have to be able to get access to my Windows certificate store. I have not heard of any attack vectors where anybody has had malware realize that you had a Fiddler certificate like that and somehow got in between your browser and server and was able to poke into your certificate store and use it to do that. I never say never, right? I have never heard of that. But certainly you have something on your machine, a server. You're basically a certificate authority on your own machine and are spitting out certificates that your browser trusts. So I don't lose a lot of sleep over that, but there are potential vectors there, I suppose. I want to talk about some tools quick. So again, these have SSL in their name. You know, I didn't write them, sorry. I would call them bad TLS today, but if you come out there, this bad SSL, the purpose of this is it will let you see what a browser will see in certain situations. So in other words, if you want to see what Edge is going to do when it runs into an expired certificate, it's hard for you to set up some of these things. But if I click this, oh, hold on here, I got to close out my fiddler because that's going to get in my way. Come on, let me close. If nothing else, right? So if I hit this again, I'm going to restart my browser. Bear with me, sorry. Why am I not connected? Sometimes it'll get messed up about, so let me try that one more time. Okay, so now I can see this is what a browser will look like when it runs into an expired certificate. You know, what will a browser look like when it sees we talked about self-signed certificates, right? It'll say the certificate authority is invalid. So it just lets me go see for a given browser all of these kind of problems and what they would actually look like at a browser level. Like if I've got poor cipher suites or some of these other things. That's just a cool way to be able to see how a browser, like what a customer's experience would be like in that particular case. The next one that's useful is this SSL test. So I can punch in my domain name, and I'm not going to do this because it'll take too long. I'll show you my finished report. I ran it against my Azure website, and it gives me a score. So Azure websites, you know, the way they're configured from a security perspective, there's a lot of best practices in here, and they score the way it's set up as an A. So it goes into here, it shows you my wildcard certificate. It talks about, I mean, there's all sorts of gory level HTTPS stuff you can get into. You know, which RSA what ciphers am I using? All that stuff is in here. This is meant for you as an administrator to check that you're running your HTTPS in a secure configuration. So you can see Azure Websites is using TLS 1.2. They have 1.1 and 1.0 shut off. They don't have 1.3 on yet. I was talking about the cipher suites. Here are the suites that the server is willing to do in preference order. And you can see there's a bunch of weak ones. So there's good ones, but because the server still has these ciphers installed, they allow the browser to negotiate what they want to use. So technically I could shore up my security by taking all of the weak ciphers off. That way I could make sure that only the strong ones are being negotiated. Now that might knock out some of the browsers or devices my site would support. So if I had an ancient browser my site was using that only supported maybe, you know, one of these, that won't work anymore, right? So normal trade-offs in life. When do you want to increase your security by knocking out some of the people who might be able to use your site? So again, go ahead.
Other than knocking out some people potentially, what else is preventing people from just jumping to 1.3?
So 1.3, the problem right now is server support. So like there are no, last time I checked, there are no Windows IIS versions that support TLS 1.3, for instance. It's new enough that they don't have it in the product yet. Azure websites, I went out looking today and I didn't see where I could flip on TLS 1.3. So where I host my website might not be able to support TLS 1.3 today, right? So that would be something that would keep me from moving to it. So when we talked, I use a CDN. CDNs are usually ahead of the game. And so my CDN actually supports TLS 1.3. So I could turn that on and all of my images, CSS, JavaScript could use TLS 1.3 with the browsers that support it. Because you saw earlier, the browser support is pretty good. It's more the server side that tends to be lagging. I don't get into it too much here. We'll see if we have time or if anybody has interest. If you have a website and you're hosting it somewhere where you just can't get HTTPS to work, if you've heard of Cloudflare before, They're really popular. They will reverse proxy for you. So you might be in a situation where you said, I really want to use TLS 1.3. My backend server doesn't support it. You could look at using something like Cloudflare and let the traffic go through them first and enforce TLS 1.3 with them, and then let them reconnect to your backend using the lower, because then at least a majority of your exposure is covered, like the last mile. Kind of depends on your threat model, right? Where are you most likely to get attacked? There's a lot of bad stuff that's happening at the coffee shop on Wi-Fi. You know, the last mile stuff Cloudflare would take care of for you. But to answer your question quickly, it's hard for me to just flip on 1.3 just because the server support isn't there. This stuff here is not a TLS 1.3 necessarily. You can still go into your servers and say, even though I'm going to run TLS 1.2, I'm going to take all these ciphers out. Like I can individually, and I don't know how to do that. Like I said, I don't do this on my own machines. You can choose some of your ciphers at a Windows or IIS level and be able to take out, because I know as a company we've done that before. We've had particular weak ciphers that scans told us to take off. So I believe you'd be able to take off these ciphers, still claim that you're TLS 1.2 because that's still the protocol. And then the server would say, let's say I want to knock out all of these. I would say I only support these two. You're still TLS 1.2. As long as the devices support one of these two, you're golden, and you're using good ciphers and encryption strengths. And if you happen to have an ancient device that can't support either of these two specific ciphers, you can't connect. And that's where I'm saying that's the trade-off of taking some of these out might wipe out some of the people who can visit my site. The last one, security headers, I just want to mention it just because it also checks your server, but it's looking for more of the secure response headers and stuff. Couple quick resources. There's a good book if you want to see how the TCP connection, TLS, all that stuff. This is a free book on browser networking that's good. If you're still in doubt, does my site need HTTPS? I recommend you go to that site. Yes, you do. And any of the arguments people typically give, they try to address here. Like things I talked about, I can't afford a certificate, they're free. Here's a link to Let's Encrypt. So if you still have something that you think is an argument for why you shouldn't go to it, come and check this out. If you know Troy Hunt, this is hilarious. Somebody had an HTTP only static site, and they came to him on Twitter and were arguing with him, we shouldn't have to use HTTPS. He said, nobody could do anything to my site anyways. I'm only static site with HTML. Nobody can do anything if I use HTTP. So Troy asked the question you should seriously consider your answer to. He said, do you mind me using you as a demo site then? I'll show you what people could do with your site because you're not using HTTPS. And the person actually said, yes, go ahead. Go read the article because it's just hilarious. The things that Troy did he didn't hack his site. So I'm not saying he hacked the server and changed the HTML. That's not the point. He could intercept things in between client browsers and that person's server to manipulate things. And so you can go see all the things that he was able to do. It's very funny. There's also why no HTTPS. This has not been kept up to date as much, but they're basically shaming major websites that don't use HTTPS. So you can come out here and find it hasn't been updated since like last January. Troy's been busy. Him and Scott Helm is another big security researcher. This hasn't been updated, I don't know why, for about a year. But you can come out here and find major websites that don't use HTTPS. Again, that's my Twitter, email, blog. That's a link to, I think the code part is probably a lie because it's probably just slides. No, I do have the code for that because I do have the CSPs and stuff. So you can go out there and get to see how to do those content security policy headers and those kinds of things. So that's all I had, but I'm open if there's other specific questions people had about things.
Thank you, Robert. Anybody have questions? All right. I will take that as a no. Last chance. Okay.
And if you do have questions after the fact, reach out to me on any of those, and I will get back to you with what I can. So
Thank you.
thank you for having me, and that's all I had then.
Thank you. If anybody came in late, there is a link in the Slack channel to the stream. It is recorded, and you can share that with anybody if you want to. So it's all out there. Thanks, Robert. Thanks, everybody.
Yep,
See you next
welcome.
month. If anybody has any questions now, you can ask them. No? Okay.
Thank you.
You're welcome.
All right. Thanks, everybody.
All
See
right.
you next month.
See ya.